Welcome to the Ultimate C++ course. In this course, you're going to learn everything you need to know about C++, from the basics to more advanced concepts, so by the end of this course, you'll be able to write C++ code with confidence. If you're looking for a comprehensive, easy to follow, well-organized, and practical course that takes you from zero to hero, this is the right C++ course for you. You don't need any prior knowledge of C++ or programming in general. Everything you need to know about C++ is in one place, so you don't need to jump back and forth between random tutorials. If you're here, be sure to subscribe as I upload new videos all the time. Now let's jump in and get started. C++ is one of the most popular programming languages in the world and is the language of choice for building performance-critical applications, video games, device drivers, web browsers, servers, operating systems, and so on. That's why it's used by large companies like Adobe, Google, Microsoft, Netflix, and even government agencies like NASA, just to name a few. Every 3 years, we get a new version of C++, and the latest version at this time is version 20. The next version is coming out next year. Now, there are people like our famous superstar developer, John Smith, who think that C++ is no longer relevant because of the newer languages like Java or C#. That is not true. C++ is still one of the fastest and most efficient languages available. So if you want to build an application that needs to be fast and use memory efficiently, C++ is a great choice. This is an advantage that it has over languages like C# and Java. C++ is also one of the first languages often taught to computer science or software engineering students because it has influenced many programming languages like C#, Java, JavaScript, TypeScript, Dart, and so on. So if you're looking for a job as a software engineer, learning C++ is a great investment and opens a lot of doors for you. According to Indeed.com, the average salary of a C++ programmer in the US is just over $170,000 a year. Now, to master C++, there are two things you need to learn. One is the C++ language itself, meaning the syntax or the grammar of this language. The second thing you need to learn is the C++ standard library or STL, which is a collection of pre-written C++ code that provides functionality that is required by many applications. Examples are data structures like lists and maps, and algorithms for searching and sorting data. These functions are required in almost every application. So instead of us creating all this functionality from scratch every single time, we can reuse some of the C++ code in this library to quickly build applications. In this course, we'll explore major functionalities in the standard library, but the standard library is huge, so we'll only scratch the surface. If you want to learn more, there are books specifically written on this topic. Now, a lot of people find C++ a bit extensive and intimidating, but in reality, you don't need to learn all of C++ to be able to write substantial programs. For the same reason, you don't need to learn every feature your TV provides just to use and enjoy it. So in this course, we're going to explore C++ step by step, and as we go, I'm going to show you how you can write some really cool programs as you're learning C++. Plus, I'm going to give you plenty of exercises to help you better understand and remember the concepts. Then you will see that C++ is not really that difficult. So if you follow along, by the end of this course, you'll be able to write C++ code with confidence. Alright, next we're going to talk about the tools you need to write C++ programs. To create C++ programs, we use an integrated development environment or IDE, which is basically an application that contains an editor for writing code, as well as build and debugging tools. Now, there are so many different IDEs out there. Some of them are free, the others are commercial. But the top 3 ones are Microsoft Visual Studio for Windows. The Community Edition is free, you can get it from the link on the screen. There is also a Mac version, but the one on the Mac is not really that great. For Mac, you can use Xcode, which you can get from the App Store. We also have CLion, which is cross-platform, so it runs on Windows, Mac, and Linux. You can try it for free for 30 days, but then it requires a license. If you don't want to pay for a license, you can use one of the free alternatives. Again, there are so many different IDEs available for creating C++ programs. In this course, I'm going to use CLion, but you don't have to use it to follow along. You can use any tool you prefer because our focus here is not on tooling, it's on the C++ language itself. Now, if you're an absolute beginner and you have never coded before, I recommend you to download the free version of CLion so you can easily follow along, and then later you can either get a license or use one of the free alternatives. So head over to jetbrains.com/clion/download. Again, you can see we have versions for Windows, macOS, and Linux. Just note that if you're on Mac, make sure to download the right DMG, because here we have two different builds. One is for Intel, the other is for Apple Silicon. So depending on the type of processor that your Mac uses, make sure to download the right DMG because the difference in performance is significant. All right, so go ahead and install this. In the next lesson, we're going to create our first C++ program together. So the first time you open CLion, you're going to see this pop-up box for activating your license. For now, just select Start Trial. Now you need to log into your JetBrains account. Now back to CLion, we can start our trial. Now on this page, we're going to click on New Project. Now on the top, we can specify the location of this project. So on my Mac, it's going to be on users/my name/CLion project. I'm going to call this project Hello World, all in one word, without any spaces, okay? Now over here, we can specify the C++ language standard. So by default, version 14 is selected, but we can change that to a higher version like 20 or 23. Now, because 23 is not official yet, I would suggest you to go with 20. Good. Now let's create this project. All right, here's our first C++ program written in a file called main.cpp. If you accidentally close it, you can easily find it in the project window. So expand this folder, and here is main.cpp. Now we have another file in this project called cmakelist.txt. We don't need that, so let's close it from here. Now we have the same concept in other IDEs like Visual Studio or Xcode. So we have a project, and that project contains a file that is the main file of our program. Now let's close this window. I'm going to delete all this code because we're going to write it from scratch so you understand how everything works. All right, let's start with a metaphor. Think of your TV. Your TV has several functions. It has functions for changing the channel, controlling the volume, and so on. By the same token, a C++ program consists of tens or hundreds or thousands of functions, each serving a purpose. Now we have a special function here called main, which is the entry point to our program. This is like the power button of a TV, okay? Now note that C++ is a case-sensitive language, so it's sensitive to lowercase and uppercase letters. So make sure to type this exactly as I show you. So if you type a capital M here, this is going to have a different meaning, okay? So we're defining a function. Now before the function name, we should specify the type of value it's going to return. This main function should return a value of type int, which is short for integer, and that represents a whole number like 1, 2, 3, 4, and so on. So when we run our program, the operating system like Windows or Mac OS is going to execute this function, and the value that this function returns tells the operating system if our program terminated successfully or not, okay? So here we have int followed by a white space and then the name of the function. Now white spaces in C++ are often ignored, so whether we have 1 or 10 spaces, it doesn't really matter. But in terms of formatting our code, it's better to go with 1 space because we want to format this code professionally, just like how we write an article. We want to format our code just like a published article, okay? Now, after the function name, we type a pair of parentheses, and inside the parentheses, we can specify the parameters of this function. So a function can have 0 or more parameters. For now, let's not worry about them. We'll talk about them later. Then we type a space, again for proper formatting, followed by a pair of braces. Now inside the braces, we can type the code for this function. So whatever we type here will be executed when the operating system executes our main function. Now, once again, in terms of formatting, there are 2 schools of thought for adding the braces. Some people like to add the left brace on the same line as the function. The other people like to put the left brace on a new line. There's really no right or wrong here. So whatever you prefer, just stick to that and make sure your code is consistent. In this course, I'm going to put the left brace on the same line where we define a function, okay? Now, in this function, we want to write code to print something on the screen. And for that, we're going to use the C++ standard library. So earlier I told you that the standard library provides a bunch of capabilities that we need in almost every application. So on the top, we type hashtag include, and in angle brackets, we specify the name of one of the files in the standard library, that is IO stream, which is short for input output stream. In this file, we have capabilities for printing something on the screen or getting input from the user. So just like a supermarket has different sections, the standard library also has different files, each serving a purpose. Now, as we go through the course, you will learn about the other files in the standard library, okay? So back to our main function. Now here we type std, that is short for standard library. And this is like a bucket or a container for the features that are currently available to us. So the features we have imported on the top, okay? So if we type double colons, we can see all these features. Now there are a ton of features here, don't worry about any of them. In this lesson, we're gonna use cout. That is short for character out. Some people think this is short for console out. That is not correct. So using this object, we can output one or more characters on the screen. So we type a space, followed by 2 left angle brackets, another space, and then in double quotes, we type the text we want to print on the screen. So hello world, okay? And then we terminate this line using a semicolon, just like how we terminate our sentences with a period. So in C++, this line is called a statement because it tells the operating system what to do. So whenever we type a statement, we should terminate it with a semicolon, okay? Now finally, we return the value of 0, and once again, we need to terminate this with a semicolon. But why 0? Well, 0 tells the operating system that our program is going to terminate correctly. If we return any other values, positive or negative, that means our program encountered an error, okay? So let's quickly recap what we have done so far. On the top, we included one of the files in the standard library for printing something on the screen. Then we defined the main function, which is the entry point to our program. Now, as you can see, the main function returns an integer, which is a whole number like 0, 1, 2, 3, and so on. And in between the braces, we have written the code for this function. So on the first line, we print something on the screen. And on the second line, we return the value of 0. As simple as that. This is your first C++ program. Next, I'm going to show you how to compile and run this program. Now, to run this program, first we have to compile this code to machine code that can be run by the computer's operating system. So the machine code is basically the native language that a computer's operating system understands, and it's different from one operating system to another. So if we compile this code on a Windows machine, we get an executable, but that executable only runs on Windows. We cannot run it on Mac or Linux. If you want to run our application on a Mac computer, we have to take this code on a Mac and recompile it to get an executable from Mac, okay? So back to our code. To run this program, we're going to click on this play icon on the toolbar. Now look at the shortcut. On Mac, it's Control and R. Always use shortcuts because they make your life easier. So let's run this program. We get this little window down the bottom. This is called the console or the terminal window. It's basically a way to see the output of our program. So over here, you can see the hello world message. So we're using a console application here because console applications are easier to create, especially for people learning a new language. Building applications with a graphical user interface or GUI is way more complex. So once you understand the basics of C++, you'll be ready to move on to writing applications with a graphical user interface if that's what you want, okay? Now, let's minimize this window and make a tiny problem in this code. So I'm going to remove this semicolon. Now, let's rerun our program. All right, look, this time we get a compilation error pointing to this line. So the error is reminding us that we have forgotten a semicolon. If you're starting out, it's completely normal to encounter these errors if you have a typo or miss a semicolon and so on. Don't let that discourage you. Remember, patience is the first skill of a good programmer. So if your code doesn't get compiled, pay close attention to this video, see what exactly I'm typing, compare it with your code. I promise, if you pay close attention, you'll be able to solve issues on your own. So let's fix the issue. All right, let's move on to the next lesson. Now going forward, I want to change the colors here, and I wanted to show you how to do that because a lot of people ask me about the themes I use in my videos. If you're not using CLion, feel free to move on to the next lesson. So on the top, we go to the Preferences menu. Then under Appearance and Behavior, we select Appearance. Now over here, you can see the themes that are installed by default. We only have 4 themes, but we can get more themes by clicking on this link. Now on this page, I'm going to sort this list by the number of downloads so we can see the popular ones. I'm going to pick Dracula theme. It's a very popular theme, but feel free to play with these themes and find the one that you personally like. So let's install this. Accept. Good. Now, okay. So this is the Dracula theme, which is much better than the default theme that comes with CLion. So that brings us to the end of this section. In the next section, we're going to talk about the basics of C++. So I will see you in the next section. This course is the first part of my complete C++ series. Each part is about 3 to 4 hours long, so you can easily complete it in a day or 2. In the first part, which is the one you're watching, we explore the basics. In this part, you will learn the fundamentals of programming in C++, data types, decision-making statements, loops, and functions. Now, throughout the course, I'm going to give you plenty of exercises to help you develop your problem-solving skills and build your confidence in writing code. In fact, many of these exercises are popular interview questions. In the second part, we'll explore intermediate-level concepts such as arrays, pointers, strings, structures, enumerations, and streams. And finally, in the last part, we'll be talking about the advanced concepts such as classes, exceptions, templates, containers, and more. So by the end of this series, you will have a solid understanding of C++ and you'll be ready to apply it in real life. For example, if you want to build games with Unreal Engine, which is a popular gaming engine, you will have the necessary C++ skills to build games. You just need to learn about Unreal Engine. So I hope you'll stick around and master C++, one of the fastest and most. I've put together a complete cheat sheet and summary notes for you that you can download as a PDF right below this video. So click the link in the description to download it by liking and sharing this video. And also be sure to subscribe as I upload new videos all the time. Welcome back to the Ultimate C++ course. In this section, we're going to talk about the basics of C++. We'll cover variables and constants, naming conventions, coding mathematical expressions, writing to and reading from the console, working with the standard library, and comments. So by the end of this section, you'll be able to write simple but really useful programs in C++. Now, let's jump in and get started. All right, let's talk about variables. In programming, we use variables to temporarily store data in the computer's memory. Now, technically, a variable is the name of a location in memory where we can store some value. Now, because the value can change, we refer to this location as a variable. Now, to declare a variable in C++, first we have to specify the type of data we want to store. Let's say int or integer for storing whole numbers. Then we give our variable a proper, meaningful name, like file size. Now, there are various ways to name our variables. We have various conventions. We'll talk about them momentarily. Once we declare a variable, then we terminate this statement with a semicolon. Now, I want to emphasize that you should always use meaningful names for your variables. Don't use abbreviations like fs, because someone else reading this code may not know what fs is short for. Also, don't go for names like f1 or f2 or thing. These are all cryptic and ambiguous, okay? So we're going to call this file size, and then we can give it a value like 100. So we assign it the value of 100. Now here we can combine these two statements into a single statement, and that makes our code shorter and more concise. So right here, where we declare our variable, we can give it an initial value of 100. This is called initializing a variable. Now, we don't need the second line, okay? Now let's declare another variable for storing numbers with a decimal point. For that, we're going to use a different data type, that is double. We're going to talk about different data types in the next section. So in this section, we're only going to work with integers and doubles. Now we're going to call this sales and initialize it to 9.99, okay? Now that we have two variables, we can print them on the console. So instead of hello world, let's print file size. Run our program, we see 100, beautiful. Now, while initializing variables is not mandatory, it's a good practice to follow. Let's see what happens if we don't initialize file size and print it on the terminal. Well, immediately we see this warning. Let's take a look. The warning is saying variable file size is uninitialized when used here. Initialize local variable file size. So our IDE is complaining that we are using a variable that doesn't have an initial value. Let's run our program and see what happens. Take a look. Look, we get this random value, and if we run our program multiple times, we see a completely different value. This is what we call garbage. This is the data that is currently in memory. So, as a best practice, we should always initialize our variables before using them. So I'm going to set this to an initial value of 0. Now, in languages like C# or Java, we don't have to do this. If we declare an integer, it automatically gets initialized to 0. But this is not how it works in C++, okay? So this is how we can declare and initialize variables. And by the way, we can also initialize multiple variables on the same line. So over here, we can declare a second integer. Let's call that counter. So we add a comma and then declare counter, and optionally, we can initialize it to some value. Now, while this works, it's often discouraged. As a best practice, we should declare each variable on a separate line. So I'm going to remove this and declare another integer like this, okay? Now I have a small exercise for you. I want you to write code to swap the value of two variables. This is a common interview question, so let me explain what I mean. We're going to declare two variables, A and B. Now if we print A, we're going to see 1 on the terminal, right? Now here's what I want you to do. Over here, I want you to write code to swap the value of these variables. So when we print A, we see 2, and when we print B, we see 1. Now I don't want you to reset these variables, so I don't want you to set A to 2 and B to 1. This is not the right solution. Let me give you a hint. Imagine instead of these two variables, we have two buckets. The first bucket is filled with apples. The second bucket is filled with oranges. Now, if we have these two buckets in real life, how can we swap their content? Think of a solution and then use that idea to write code to swap the value of these variables. It's not that difficult. Just spend a couple minutes on this and then come back see my solution. So to solve this problem in real life, we need a third bucket. First, we empty our apples bucket into this bucket. Now the apples bucket is empty, so we can move the content of the oranges bucket here. Now the oranges bucket is empty, so we can move the content of the third bucket into this bucket. Now we have swapped the content of our buckets, right? So let's use this idea to solve this exercise. We declare a third variable, we can call that temp, and we initialize it with what we have in A, that is the value of 1. Now we can set A to B, so whatever we have in B, which is 2, is now going to be in A. And finally, we're going to set B to temp, so B is going to be 1. So now, if we print A, we're going to see 2 instead of 1. Let's verify this. So let's run our program. There you go. Beautiful. So this was your first programming problem. If you got stuck, don't worry. It's completely normal. As we go through the course, I'm going to give you more and more exercises to help you build your confidence. Next, we're going to talk about constants. There are situations where we don't want the value of a variable to change. This is where we use constants. Here's an example. Let's declare a variable of type double and call it pi and set it to 3.14. Now, with this, we can calculate the area of a circle, right? But what if somewhere in our program, I accidentally set pi to a different value, like 0. With this, our calculations are going to go wrong, right? This is where we can use a constant to prevent the value of pi from changing. How do we do that? Very easy. We type the const keyword before declaring this variable. Now look, on line 5, we have a red underline. That is a compilation error. So if you hover our mouse here, we see the error saying cannot assign to variable pi with const qualified type const double. And also, if you try to run our program, here in the terminal window, we see an error. So take a look. This is the error. The error is happening in main.cpp on line 5 in column 8. And here's the actual error. Cannot assign to variable pi with const qualified type. Okay? So this will prevent us from accidentally modifying the value of this variable, or more accurately, constant. Now let's talk about naming conventions. So we have different conventions for naming our variables and constants, and different teams prefer different conventions. So there is really no right or wrong here. But let me show you the popular conventions. So earlier we declared a variable called file size. The way we name this variable follows what we call the snake case. So with this convention, we have to use lowercase letters to name our variables and constants. And if we have multiple words, we should separate them using an underscore. Now we have another convention called Pascal case, in which we should capitalize the first letter of every word. So the same variable using Pascal case looks like this. This is Pascal case. And by the way, the text that I put here that starts with 2 forward slashes, this is called a comment. We'll talk about comments later in this section, but for now, just remember that comments are a way to describe our code. They don't get compiled, okay? Now we have another convention that is similar to Pascal case. The only difference is that the first letter of the first word should be lowercase. So, file size. This is camel case. We also have Hungarian notation, which is a pretty old notation and it's not relevant anymore. With Hungarian notation, we should prefix the name of our variables with a letter that specifies their type. So here we have an integer, so we use a lowercase I and then file size, just like Pascal case. This is called Hungarian notation. Now, quite frankly, this is a very old notation. It's not relevant anymore, but I still see people using it. I've seen it a lot in Windows source code. The reason this is not relevant anymore is because in the old days, we didn't have good editors. So if we declared a variable somewhere and we wanted to know its type, we had to scroll up to find the type of that variable. So with Hungarian notation, we could look at a variable and immediately tell its type. But this is not the case anymore because these days we have powerful editors. If we simply hover our mouse over any variable, we can see its type. So here you can see file size is an integer variable, right? So these are the popular conventions out there. In this course, I'm going to use camel case for naming our variables and constants, and Pascal case for naming our classes. We'll talk about classes later in the course. Now, if you don't like these conventions and prefer to use snake case, that's totally fine, but make sure to stick to your own convention. The more consistent your code is, the easier it is to read, understand, and maintain it. Next, we're going to talk about mathematical expressions. So you have learned how to declare variables and constants. Now let's see how we can write mathematical expressions for performing calculations. This is where the fun begins. So I'm going to declare two variables, x and y. Now we can declare a third variable and set it to x plus y. So what we have here is called the addition operator, and x and y here are called operands. So now let's print z on the terminal. So std :cout z. Take a look. So now we see 13. Beautiful. We also have subtraction, multiplication, and division. But division is a little bit tricky. In this case, because we're dealing with two integers, the result of the division is going to be an integer, even though in reality, dividing 10 by 3 is going to result in a number with a decimal point, which we call a floating point number in programming. So if you run our program, we see 3, but what if you want to see a floating point number? Well, changing the type of z to double is not going to solve this problem because, as I told you earlier, if both our numbers are integers, the result of the division is also going to be an integer. So to get a floating point number, we have to convert one of these numbers to a double. So take a look. First, the warning goes away. Now, if we run our program one more time, look, we get 3.3333. Okay? So this is how division works in C++. Now let me revert this back to integer and integer. Now we have another operator called modulus, which returns the remainder of a division. So what is the remainder of division of 10 by 3? It's 1. Let's verify. There you go. Okay? Now using these operators, we can modify our variables. Let me show you what I mean. So for simplicity, I'm going to remove y and z. We only have x and we're going to print it on the terminal. Let's say we want to increment x by 5. Here's how we do it. We type x equals x plus 5. So first, this piece of code or this expression is going to get evaluated. The result is 15, and then the result will be stored in x. Okay? Now similarly, we can subtract 5 from x, we can multiply x by 5, and so on. Okay? Now we also have two more operators you need to know, and they are increment and decrement operators. So let's say we want to add 1 to x. We can say x equals x plus 1. That is totally fine, but there is a shorter and more concise way to write this code. We can say x plus plus. This is the increment operator. We also have decrement operator, but we don't have the equivalent for multiplication or division. Only increment and decrement, okay? Now, this increment operator, there are two ways we can apply it. We can apply it as a postfix or as a prefix. Let me show you the difference. So I'm going to delete these two lines. Let's declare another variable called y and set it to x plus plus. If we apply this as a postfix, first, the current value of x, which is 10, is going to be assigned to y. So y is going to be 10, and then x will be incremented by 1. So if you run our program, x is going to be 11, but y is going to be 10. Let me show you. So we print x is 11, but if we print y is going to be 10. Okay? So let me add this as a comment for clarity. In this case, x is going to be 11 and y is going to be 10. Now, what if we apply the increment operator as a prefix? So we declare another variable and set it to plus plus x. In this case, because we applied this operator as a prefix, first, the value of x is going to be incremented by 1. So x is going to be 11, and then the result will be stored in z. So in this case, both x and z are going to be 11. Let's verify it. So if we print z, well, in this case, z is 12. I made a mistake because in the previous statement, we incremented x by 1. So if we comment out this line, it's not going to get executed. So now, when we run our program, x is going to be 11 and z is going to be 11 as well. Let's verify it. So here is z, beautiful. And let's also print x. There you go. So here's what you need to take away. If you apply the increment or decrement operator as a prefix, first, this piece of code is going to get evaluated. So first, x is going to be incremented by 1, and then the result is going to be stored in the other variable. In contrast, if we apply this operator as a postfix, first, the current value of x, which is 10, is going to be stored in y, and then x is going to be incremented by 1. Thing you need to know from the basics to more advanced concepts. So watch this tutorial to the end, and if you still want to learn more, use the link below this video to enroll in the full course. The complete course contains 3 parts, each part being around 3 to 4 hours long, so you can complete them in a day or 2. You will also get a certificate of completion and a 30-day money-back guarantee. Again, if you're interested, the link is below this video in the description box. Mathematical expressions, especially the more complex ones, you need to take into account the order or priority of operators. Let me show you what I mean. So I'm going to declare a variable called x and set it to 1 plus 2 times 3. Now, let's print x on the console. What do you think we're going to get? Pause the video and think about it for a second. The answer is 7. This is a very simple math question, but unfortunately, a lot of people get it wrong. Here's the reason. In math, the multiplication and division operators have a higher order or a higher priority. So when evaluating this piece of code or this expression, first, this part is evaluated. So 2 times 3 is 6. And then 6 is added to 1. So the result is 7. Let's verify it. So I'm going to run the program. There you go. We have 7. Okay. So here's what I want you to remember. In math or any programming languages, the multiplication and division operators always have a higher priority than addition or subtraction operators. But we can always change the order of these operators using parentheses. So in this case, if we wrap this piece of code with parentheses, first, this piece is evaluated. So 1 plus 2 is 3, and then 3 is multiplied by 3. So the result is going to be 9. Let's verify it. So run the program one more time. There you go. Okay. Now here's your exercise for this lesson. Take this mathematical expression and implement it in C++. Assume x is 10 and y is 5. So if you implement this correctly, z is going to be 1.3. So pause the video and work on this for a couple minutes, then come back see my solution. Alright, here's the solution. I'm going to declare x and set it to 10. Then y, we set it to 5. And for z, first we have to add 10 to x, but we have to wrap this in parentheses because this whole thing is going to be our numerator. Once we have the numerator, then we're going to divide it by 3 times y. But here's the tricky part. We have to wrap this whole expression in parentheses because the result of this expression is going to be our denominator. If we don't use parentheses here, our denominator is going to be 3 and the result is going to be different. So we wrap this whole thing in parentheses, and now let's print z on the terminal. So we should get 1.3. Again, if you didn't solve this properly, don't worry, don't let that discourage you. Remember, you're a student, you're learning. If you know everything and you could solve every problem, you would be the one teaching, right? So don't let that discourage you, and let's move on to the next lesson. So you have learned how to write to the console or the terminal window. In this lesson, I'm going to show you a few more techniques for writing to the console. So let's start by declaring a variable. Now let's say on the terminal, we want to print x equals 10. How do we do this? Well, first we go in the std namespace and pick up cout, which is an object that represents the standard output stream. I know, it's a mouthful, but let me explain it for you. In programming, a stream represents a sequence of characters. The standard output is our console or terminal window. So using cout, we can write a sequence of characters on the standard output, which is our console window, right? Now, these double left angle brackets are called the stream insertion operator. It's an operator for inserting something to our output stream. In this case, we're going to write a sequence of characters which we specify using double quotes. Now in programming or C++ specifically, this is called a string. We'll talk about strings later in the course. So here we want to print x equals, and right after we want to print the actual value of x. So we terminate this statement and use cout one more time. But this time we print x, okay? Let's run our program and see what we get. So we see x is 10. Beautiful. Now, we can combine these statements into a single statement. So we get rid of the second cout and this semicolon, and then put everything on the same line. Now we are chaining multiple stream insertion operators. So if we run our program one more time, we get the exact same result. Beautiful. Now, what if we declare a second variable? So let's declare y and set it to 20, and then repeat. So one more time, cout y equals, and then we add y. Take a look. All right, here's what we get. But wouldn't that be nicer if y equals 20 was on the second line? Well, to solve this problem, right here, we need to add a new line. So once again, we chain the stream insertion operator, and this time we go in the std namespace and pick up endl, which represents the end of the line. Okay, now let's run our program one more time. That is much better. Okay, now once again we can simplify this code by combining these two statements. So again, we don't need the second cout, so let's remove that and this semicolon as well. Now if we run our program, we get the exact same result. However, our code is not formatted properly. It's a little bit hard to read this code. So here I'm going to use tabs and spaces to align these operators. So what we have in our code looks exactly like what we expect in the output. Okay, this is better. Now there is a tiny problem in this code. We have a bit of repetition of std double colons. So we have repeated this in two places. Let me show you how to simplify this code. So before our main function, we use the using directive to pick up the std namespace. So here we type namespace std. Now std is defined anywhere in this file, so we don't have to repeat it in multiple places. So we can simply access all objects in the std namespace. So let's remove that, and this one as well. And finally, let's realign these brackets. Great. So now our code is cleaner, more concise, and easier to read. Great. Now here's your exercise. Imagine you have a store and you have made $95,000. Now as part of your tax return, you have to pay state and county tax at different rates. So state tax is 4%, whereas county tax is 2%. Now I want you to write code to show your total sales, as well as your state tax, your county tax, and the total tax you have to pay on this income. So pause the video and work on this exercise for 5 minutes, then come back see my solution. All right, here's my solution. First, we need a variable for storing the total sales. And for that, I'm going to use a double. So even though we don't have any cent values here, but for monetary values, we should always use a double. So double sales equals 95,000. Now, right after, let's print the total sales. Here we add a $sign. That's nicer. Then we chain the insertion operator to print sales, followed by the end of line. Now, before going any further, let's run our program and make sure everything works. So, run. Total sales is $95,000. Great. Next, we need to calculate the state tax. So let's declare another variable called state tax. And here we get sales and multiply it by 0.04. And then once again, we print this on the terminal. So state tax is this value, followed by the end of line. Now, once again, let's run our program and make sure everything works. So this is how I want you to write code. Write a bit of code, run it, make sure everything works before going further. Baby steps. So run. So our state tax is $3,800. Great. Now let's improve this code. The first thing I want to improve here is formatting. So the first two lines are about the total sales, whereas the second two lines are about the state tax. These are two different stories, right? So here I add a vertical line to separate these stories. Just like how we have multiple paragraphs in an article, we want to write our code so every story is separated from other stories, okay? So here's our state tax. Then I add another vertical line to separate it from the return statement. Great. Now, this line is totally fine, but generally speaking, it's best to avoid magic numbers like this here, because even though this is a very simple example, in more complex programs, these magic numbers might be confusing. Someone else reading your code may not know what that number represents. So here we can make our code more expressive by storing this value in a separate variable. So we declare a variable called state tax rate and set it to 0.04. and then we can reference that variable right here. Now it's completely clear what this value represents. It's our state tax rate. But this has another benefit. If we use this variable in multiple places in our code, and then tomorrow the state tax changes, we don't have to come back and modify multiple places. We have a single place where we have stored this value, okay? Now, there is a tiny problem in this code. The problem is that I can accidentally change the state tax rate. How can we solve this problem? Using a constant. So we qualify this with the const keyword. That's better. Now we have to repeat the same 3 lines for our county tax. So I'm going to copy this and paste it. And again, note the vertical line. This is to separate these stories. So over here, we're going to rename this to county tax rate, which is going to be 2%. And over here, we're going to calculate the county tax and print it accordingly. County tax. Good. Nothing new. Now we should also replace state tax rate with county tax rate. So let me show you a shortcut here. Look, I haven't typed county tax rate. I just typed kind of an abbreviation. So count TR. So we can use abbreviations to quickly type our code and press enter to complete it. Okay. Now let's run our program and make sure everything works. So our county tax is 1900. Beautiful. Now the final part. We declare another variable called total tax, which equals state tax plus county tax. And finally, we print it on the terminal. Total tax. Okay. So once again, see how I have named my variables. All the variables are properly named. They're meaningful. There is no ambiguity in this code. We don't have T1, T2, TR, whatever. Don't write code like that. Next, we're going to talk about reading input from the user. All right, now let's see how we can read input from the console. So you have learned that cout represents the standard output string. Now in this file, in IOString, we have another object called cin, which represents the standard input string, which we can use for reading data from the console. Let me show you how. First, we're going to use cout to print a label on the screen. So enter a value. Now using cin, we can read that value and put it in a variable. But first we need to declare a variable. So let's declare an integer called value. Then we use cin along with the stream extraction operator to read that value and put it in this variable. Okay? So this is called the stream extraction operator. It's the opposite of stream insertion operator. I know it can be confusing, but the easiest way to remember this is to think of the direction of data flow. So in this case, we are reading data from the console or the standard input and putting it into this variable. In contrast with cout, we're basically getting this sequence of characters and putting them into the console. So this is the way to remember this, okay? Now, to verify that our program works, let's print the value that we just read. So let's run our program, enter a value, let's say 10, and we get 10 in the output. Beautiful. Now, what if we enter a floating point number, a number with a decimal point? Let's see. So this time I'm going to enter 10.1. The decimal part is gone because we declared this value as an integer. So if you want to read a floating point number, here we have to use the double type. Take a look. So one more time, 10.5. Now we get 10.5. Beautiful. Now we can also read multiple values. So let's change this label to enter values for x and y. Now let's declare two variables called x and y. First we read x and then we read y. And finally we can print x plus y. This is like a simple calculator. So take a look. We can enter 10 and 20 and the result is 30. Now we can also separate these numbers using a space and the program will still work. Take a look. So one more time, 10 space, it doesn't matter one or more spaces, we add the second number, and we get the same result, okay? Now, similar to cout, here we can chain these statements together. So we can get rid of the second statement and chain the stream extraction operator to read the second value. So look, we start from the console, we read something and put it in X, then we read something else and put it in Y. It's exactly like before, but our code is shorter. So this is how we can read input from the console. Now, as your exercise, I want you to write a program for converting temperatures from Fahrenheit to Celsius. So when you run your program, the program should ask the user to enter a temperature in Fahrenheit, and then it should convert it to Celsius and print it on a terminal. So pause the video and spend a few minutes on this, then come back see my solution. Alright, here's the solution. It's pretty easy. First, we use cout to print a label like Fahrenheit. Then, we declare a variable for storing the temperature in Fahrenheit. Next, using cin, we read that value and put it in this variable. Then, we declare a variable of type double called Celsius. The reason I'm using a double here is because the conversion might result in a floating point number. So, here's the formula. Fahrenheit minus 32. We wrap this in parentheses and then divide it by 1.8. Now finally, using cout, we print the temperature in Celsius. Now let's test our program. So 90 in Fahrenheit is equivalent to 32.2 in Celsius. Now that you're familiar with the basic built-in types in C++, let's look at a few different ways to declare and initialize variables. So I'm going to start by declaring a double called price, and we're going to set this to 99.99. Nothing new so far. But what if we want to declare a float? Well, we can declare a float called interest rate, and we set it to 3.67. And here at the end, we type the letter F, that is short for float. This is really important because if you don't type this, by default, the compiler will treat this number as a double, and then it will try to store a double inside a float variable, and this can potentially cause data loss. So when working with float values, always type an F at the end. It can be uppercase or lowercase, it doesn't really matter. Now there is another reason we should type this letter. We'll come back to this shortly. Now let's declare a long. So long file size. We can set this to 90,000. Now, similar to the float type, here we should add the L suffix, because if you don't type this, the compiler will treat this number as an integer. So to force the compiler to treat this as a long, we type either an uppercase or a lowercase l. Now, the lowercase l can be confused with the number 1, so the best practice is to use a capital L, okay? Now let's declare a variable for storing a character. So we say char letter, and here we use single quotes to represent a character like A, okay? And finally, let's look at a boolean. We're going to call this is valid, and we can set it to true or false. These are the acceptable values for booleans. Now with any of these types, we can also use the auto keyword to let the compiler infer the type of our variables. For example, if we change bool to auto and then hover our mouse over is valid, look, the compiler knows that is valid is of type bool. Similarly, if we change char to auto and look at the type of this variable, we can see it's of type char. Now, here's the interesting part. If we change long to auto, we can see that file size is of type long because we added the letter L at the end. If we don't type this and use the auto keyword, look, file size is treated as an integer. So that is why we need to add this suffix. Similarly, for floats, if we use auto, now we can see interest rate is a float, but if we remove the suffix, it will be treated as a double, right? So this is the benefit of using the auto keyword. It kind of makes our code shorter and more consistent. You don't have to use it if you don't like it, but the auto keyword is particularly useful when working with more complex types. We'll look at that in the future. Yeah, there's one more way to initialize variables in modern C++ that you need to know, and that's called brace initialization. So let me delete all this code and declare an integer called number and set it to 1.2. Now here we get a warning because we have a yellow underline, but our code still gets compiled. So if we print number and run our program, we see the fraction part is gone and we see 1, okay? Now there's another way to initialize this variable and prevent this kind of scenario where we assign the wrong value to a variable. So instead of the assignment operator, we use braces. So we put this value inside braces. Now look, we have a compilation error because we have a red underline. So our code is not going to get compiled. The brace initializer stops us from making such mistakes. Now there is another benefit to using brace initialization. If we don't supply a value here, our number variable will be initialized to 0. So if we run this program, we see number is 0. However, if we remove the empty initializer here and run our program again, you can see we get this random value, which we say it's garbage. And every time we run our program, we get a different value. So this makes our programs unpredictable. So we should either initialize our variables using the assignment operator to a proper value, or we should use an empty brace initializer. So you have seen that the standard library gives us the capability to read from or write to the console. Now in this lesson, we're going to look at a different part of the standard library that gives us several useful mathematical functions. So on the top, we're going to use the include directive one more time to include a file called cmath. This file declares a bunch of useful mathematical functions. Now if you're curious what these functions are, just go to Google and search for cmath reference. There are many different websites that give you a C++ reference. One of them is c++.com, the other is cppreference.com, and so on. So as an example, let's look at this page. So over here, you can see all the functions declared in the cmath library. In this lesson, we're going to look at a couple of them. One of them is ceil, which rounds up a value. The other is floor, which rounds down a value. Now, if you click on any of these functions, you can learn more about it. So on the top, you can see different versions of C and C++. So C90 and C99 represent the old C language. C++98 is one of the early versions of C++ that came in year 1998. Then we have C++11 that was released in year 2011. So you can see how this function has evolved over different versions of C or C++. Now don't get hung up too much about these details. All I want you to pay attention to here is that this function takes an input of type double and returns another double. So let's see this in action. So back to the code. Here in the main function, to use the floor function, we type floor followed by a pair of parentheses, and then we supply the input value, which is called an argument. So we pass 1.2. Now we get a double value that we can store in a variable. So let's declare a variable of type double called result and set it to the return value of the floor function. And then we terminate this statement with a semicolon. Now over here, we say that we are calling the floor function, which means we're executing it. We're giving it a value and getting a new value. Now we can print the result just like before, and the result is 1, okay? Now some functions take multiple values or multiple arguments. One of them is the pow or power function. So let's take a look. Pow requires 2 arguments. Here we need to pass 2 values separated by a comma. So if we say 2, 3, that means 2 to the power of 3. Now when we type this, client adds these labels lcpp_x and lcpp_y. These are the name of the parameters of this function. So client adds this to make our code a bit more understandable, okay? Now, if we run this, we get 8, okay? Now, as an exercise, I want you to write a program that asks the user to enter the radius of a circle, and then it should print the area of a circle. It's pretty easy. You can knock it out in a couple of minutes. Alright, here's my solution. First we use cout to print a label, enter radius. Then we declare a double variable called radius. Next we use cin to read the value the user enters into this variable. Now we declare another variable called area, and here we have to use the old formula, pi times r to the power of 2. So we can type the pi number here, but earlier I told you that we should avoid magic numbers as much as possible. So we're going to store this value pi in a separate variable, or even better, we can make this a constant. Okay? Now we can say area equals pi times, this is where we use the power function to get radius to the power of 2. As simple as that. Now finally, we use cout to print the area. Let's test our program. So if we enter 4, the area is 50.24. Alright, the last thing we're going to cover in this section is comments. We use comments to clarify our code and to make it easier to understand. As I told you before, comments don't get compiled. Now in C++, we have a couple of different ways for writing comments. We can start with 2 forward slashes, and whatever we type in front of these slashes will be considered a comment. Now we can add the slashes above a line or in front of it. Either way works. But as you can see here, we have limited space because we're basically bound to what is left here. Of course, we can write a longer comment, but then we'll have to constantly scroll to the left and to the right to see what is going on. So it's more conventional to write the comment above a line. Now, if you want to have multiple lines, again, we can start a new line of comment like this, okay? Now, in C++, we have another way for writing a multi-line comment. Instead of 2 forward slashes, we start with a forward slash and an asterisk, and then press enter. Now cline automatically generates this block of comment. These 2 characters represent the beginning of the block, and these 2 characters represent the end of the comment block. What we put in between will be considered a multi-line comment. Now different teams have different preferences in terms of which style of comments should be used, so there is really no right or wrong here. Just pick one style and stick to it. Now, one thing I want to emphasize about comments is that you should not overuse them because they make your code harder to understand and maintain. So you should use comments only to explain whys and hows, not whats. Let me show you what I mean. So here I can write a comment and say declare a variable and initialize it to 0. Well, it is obvious that that's what we're doing on the next line. So this comment is completely unnecessary and it's making our code a little bit verbose. We don't want to sprinkle our code with all these kinds of unnecessary comments. Instead, we should use comments to explain whys and hows. If we made certain assumptions while writing this code, we should comment those assumptions so in the future when we come back, we see why we did things in a certain way, okay? So that's all about comments, and that brings us to the end of this section. So I will see you in the next section. Welcome back to the Ultimate C++ course. In this section, we're going to explore the fundamental data types in C++ in detail. We'll talk about various built-in types as well as their size and limits. More specifically, we'll explore various types for representing numbers and their differences. You will learn how to generate random numbers, which is a very useful technique, especially for building games. You will also learn how to work with Boolean values, characters and strings, as well as arrays, which we use for storing a list of values. So by the end of this section, you will have a deep understanding of these fundamental data types and how to use them to write useful programs. So now let's jump in and get started. So you have seen that in C++, to declare a variable, we need to specify its type. That's why we say C++ is a statically typed language, meaning when declaring a variable, we need to specify its type, and this type cannot change throughout the lifetime of our program. Other examples of statically typed languages are C#, Java, TypeScript, and so on. In contrast to statically typed languages, we have dynamically typed languages like Python, JavaScript, and Ruby. In these languages, we don't have to give our variables a particular type. The type will be determined based on the value that we assign to these variables. and that type can change throughout the lifetime of our program, okay? So that is the difference between statically and dynamically typed languages. Now, in C++, we have a bunch of different built-in data types. So far, you have only seen int and double, but we have more built-in types that we're going to cover in this section. In this lesson, I'm going to give you a basic overview of these types, but as we go through this section, you'll become more familiar with these types. So for storing whole numbers, we have int, which takes 4 bytes of memory on most systems. This is not a hard and fast rule. Depending on the implementation, the number of bytes taken by an integer can vary from one system to another. But for the most part, you can assume that an integer takes 4 bytes of memory. In 4 bytes, we can store numbers from -2 billion to +2 billion. Now, if you want to store a smaller number, we don't need to waste 4 bytes of memory, so we can use the short type, which takes 2 bytes of memory. And in 2 bytes, we can store the values from -32,000 to +32,000. Now, for storing larger numbers, we have long, which is often the same as int on most systems, and long, which takes 8 bytes of memory and allows us to store really large numbers. Speaking of experience, most of the time you would be using short or int types unless you're working on programs that involve complicated mathematical computations. Now, for numbers with decimal places, which we call floating point numbers, we have double, which you have seen so far. The double type takes 8 bytes of memory. Now, we also have float, which takes 4 bytes of memory, and long double, which takes 8 bytes of memory as well. Again, most of the time you would be using double, especially for storing monetary values, because the float type can result in loss of accuracy. Now, we also have the bool type for storing true and false values. They're often used to represent a condition like, is this person eligible for a loan or not? We also have another built-in type called char for storing single characters. So that was a basic overview of the fundamental data types in C++. Again, as we go through this section, we'll explore these types in more detail. In math and programming, we have different number systems that serve different purposes. In our day-to-day life, we use decimal or base 10 numbers, which can contain digits 0 to 9. But computers don't understand these digits. They only understand zeros and ones. That's why we have the binary or base 2 system. So a number in this system can only contain zeros and ones. Now we can take any number and represent it as a binary. For example, the number 255 in the decimal system is equivalent to 8 ones in the binary system. It's a very long number. That's why we use the hexadecimal or base 16 numbers to shorten binary numbers. A hexadecimal number can contain the digits 0 to 9, as well as the letters A to F. As you can see, hexadecimal numbers are more compact. Now, in programming, we use hexadecimal numbers to represent colors. You probably heard of RGB or red, green, blue colors. Using only 6 digits of a hexadecimal number, we can represent any color. That's very useful. We don't have to deal with really large decimal or binary numbers. Now let's see how we can represent these numbers in C++. So I'm going to declare an integer called number and set it to 255. Now if you want to represent this number in the binary system, we type 0b as a prefix, and then we type a binary number. I'm going to type 8 ones. So 1, 2, 3, 4, 5, 6, 7, 8. Now let's print the number. Take a look. We get 255, okay? Now we can represent the same number in the hexadecimal system. So instead of 0b, we type 0x, and then we type a hexadecimal number. In this case, double F, which can be uppercase or lowercase. It doesn't really matter. Let's run our program one more time. Look, we get the same number. Beautiful. Now, most of the time, I would say 99% of the time, we use decimal numbers. But depending on the kind of application you're building, in some situations, you may want to represent a number as binary or hexadecimal, okay? Now, irrespective of how we represent numbers, our numbers can be positive or negative. If we're dealing with a positive number, we don't have to type a positive sign. It's assumed by default. But for negative numbers, obviously, we have to type a minus. Now, in C++, we have a special keyword called unsigned. If we apply this to a numerical type, that type cannot accept negative values. Now, on the surface, you might think this is a good value, but it can actually cause programming problems that are hard to spot. For example, let's print this number on the console and see what we get. So we get this really large positive number. As another example, we might initialize this number to 0, and then somewhere else in our program, we might decrement this number. Now, if we print this, instead of -1, we're going to get this really large positive number. So my suggestion is to stay away from the unsigned keyword. Just because C++ has this feature doesn't mean you should use it. That's why earlier in the course, I told you that you don't need to learn all of C++, all of its features to build useful and substantial programs. So stay away from the unsigned keyword. When working with numbers, a concept you need to understand is narrowing. And that happens when you initialize a variable of a smaller type using a larger type. Here's an example. Let's declare an integer called number and set it to 1 million. Now, to make this code more readable, we can separate these digits using a single quote. That's better. Now let's declare a short called another and set it to number. Now we immediately get this warning saying narrowing conversion from int to signed type short is implementation defined. I know, it's a mouthful. Basically, the warning is saying that because we're converting an integer to a short, this conversion is a narrowing conversion, so it's going to result in narrowing down our number, which is 1 million. So now if we print another and run our program, we see 16,000. This is the result of narrowing conversion. Now obviously, if we used a brace initializer here, we could prevent this. Our code wouldn't even get compiled. So this is another benefit of the brace initializer, okay? Now, what if we do the opposite? What if we declare this number as short and put it in an integer? Now in this case, we have a warning because this number is too large to fit in a short variable. Because as I told you earlier, using the short data type, we can store numbers from -32,000 to +32,000. So let's change this to, let's just say 100, and then put it in an integer. Now we can use the brace initializer or the assignment operator. It doesn't really matter. Let's run our program. We get 100. So the opposite is not an issue. So the short type takes 2 bytes, the integer takes 4 bytes. If you store a smaller number in the larger memory space, we're not going to encounter data loss. So the additional bytes in memory are going to be filled with 0. Alright, now let's see how we can generate random numbers in C++. This is very useful. We can use random numbers in creating games that involve rolling a dice, card, or other elements. So we have a function called rand that is defined in a library called cstdlib. So on the top, we need to include another file from the standard library called cstdlib. Okay? Now we call this function and get a random integer. So let's store it here and then print it on the terminal. Now let's run this program. So this is the number I get. On your machine, you're probably going to get something different. Now here's the thing. Every time we run this program, we get the exact same number. The reason for this is that these numbers are not really random. They're basically based on some kind of mathematical formula. So to get a random number, we need to seed the random number generator with a different value. Let me show you what I mean. So we have another function called srand, that is short for seed rand. If we seed the random number generator with the value of 5, now we get a different random value. But again, every time we run this program, we get the exact same random number. If we seed this with a different number, now our random number is going to be different. So how can we get truly random numbers? Well, we have a function for getting the current time in terms of the number of seconds elapsed from January 1970. If we use that function, every time we run our program, we're going to get a different number. Let me show you. So first on the top, we need to include another file called ctime. In this file, we have a function called time that returns the current time in terms of number of seconds elapsed from January 1st, 1970. Now to call this function, we have to give it a special argument called null pointer or null PTR. We'll talk about this later in the course. If this is too confusing for you, just use the number 0. But CLion is going to give us a warning. Don't worry about that. It's just suggesting to use null pointer. Now this returns a long value, which is elapsed seconds. So to see this in action, instead of printing a random number, let's print the elapsed seconds. Now if you run our program, this is the number of seconds elapsed from January 1st, 1970. Now every time we run our program, we get a different value, right? So we can use this to seed the random number generator. So instead of hard coding the number 6, we can use elapsed seconds. Now we generate a random number and print it on the terminal. Take a look. So every time we run our program, we get a different random number. Great. But this random number is way too large. What if we want to specify an upper limit? Well, over here, where we generate the random number, we can use the modulus operator and specify the upper limit. So if we type 10, that's going to return the remainder of division by 10. So that can only be numbers 0 to 9, right? Take a look. So now we have 2. If we run our program again, we get 9, 3, and so on. Beautiful. Now we have a warning here under rand. The warning is saying the rand function has limited randomness. Use C++11 random library instead. So in C++11, we have a different way for generating random numbers, but that's more complicated. It's not suitable for beginners. So for now, this is a good way for you to learn how to generate random numbers. Now, we can make this code a little bit more concise. In this case, we don't really need this variable elapsed seconds because anyone familiar with C++ knows that time of 0 or time of null pointer returns the current time in terms of number of elapsed seconds. So we can grab this function and pass it as an argument to the srand function. And now we don't need this extra variable. So this function will return a value, and that value is going to be passed to this function as an argument. Okay? So this is how we can generate random numbers in C++. Now, as an exercise, I want you to write a program to roll a dice. So every time we run this program, we should get 2 random values between 1 to 6. Now, to limit the range of the random number, use this formula on the screen. You will see my solution next. All right, let's look at my solution. So on the top, we are including 3 files: iostream, cstdlib, and ctype. Now in the main function, we are seeding the random number generator with the current time. Now to generate a random value, we're going to use the formula I showed you earlier. So we call the rand function and then get the remainder of division by this expression. Our maximum value is 6, our minimum value is 1, and then we need to add 1 to it. Now someone else looking at this code will probably have no idea what these numbers represent. That's why I told you that you should avoid magic numbers. So this is a great opportunity to use a constant. So we define 2 constants, constant integer min value of 1 and constant integer max value of 6. Now here we can use the short type because we don't really need to store large numbers here. So it's better to use the short type to save system resources, the memory. So we have 2 constants. Now, instead of hard coding these magic numbers, we use our constants. And this makes our code more readable and easier to understand, okay? So using the modulus operator, we get the remainder of division by this expression. Now we need to wrap the whole thing in parentheses and add the minimum value to it. This would give us a random number between 1 to 6, so we can store it in a variable called die1 or first, whatever you prefer. Then we need to duplicate this and create a second variable called second. And finally, we can print everything using cout. So first, here we chain the stream insertion operator. We can add a comma and the second variable. Now, let's run our program. So we get 3 and 4, one more time, 5 and 6, 6 and 6, beautiful. Please support me by liking and sharing this video. Thank you so much and have a fantastic day.